Okay, guys, this small unit is going to be about trig. Trigonometry is, we call it, okay, it's short, trig is for short. Trigonometry is actually the study of right angles, okay? So what we're going to be doing is looking at how that is, how we study them, okay? The study of right triangles. And so I want to start simply by giving you a little bit of a thought process here. Like, okay, so I'm going to give you a 30, 60, 90 triangle. Whoa. I'm going to try to give you a 30, 60, 90 triangle there. See if I can get rid of, oh, wow. I did not know that would happen. Let's try this again. Okay, let's try to do a 30, 60, 90. Okay, that's about a 30. And then we're going to go down here. Okay, so let's say this is a right triangle. Okay, and I'm going to go ahead and lock it down. Let's see, lock all. Okay, so let's take a look at this. So this is 30 degrees. Okay, and then you know all the angles add up to 180. So this is 90 plus 90 is 180. So this is a 30-60 triangle. It's a really common one. What I want you to think about is that, and what they thought about it, is that when you have right triangles, if you were to take, and I'm going to call this side A, I'm going to call this A, I'm going to call this C, and this is little c, and this is capital B, and this is little b. A, B, C, A, B, C. Okay, the way we name triangles and sides is that imagine you are in the picture and you are standing at point A. The side opposite you usually has the opposite name. So A goes with A, C goes with C, although we typically don't use that one, and B goes with B, because the hypotenuse is always going to be the hypotenuse, and 90 is always going to be 90, so it's not quite the same way. Okay, so here we go. See? Big B, little b, opposite sides, okay, to the angle. But what they were doing when they looked at right triangles, what they noticed, and what you would notice too, is that, let me see, I guess I'm going to go purple. Okay, is that, check it out. What they said is, what happens if I take this side, okay, and I put it over, for example, A, okay? What they got was a ratio. And it is unique to this triangle. Okay, in other words, the minute I make this side like longer, this angle bigger, I'm going to get a different ratio. So, for example, if I have a triangle that is 40 degrees, and this is 90, and this is 50 degrees, this side, B, let's call it B2, okay, this side over this side is going to be a completely different ratio, but it's basically almost like it's so unique to that triangle, it identifies that triangle. It's just almost like a fingerprint, so to speak, of a 90-degree angle. And what they noticed is that if you take, actually this is fine, if you take a parallel line, okay, and draw it, that one didn't go well. Let's try this again. If I take and draw a parallel line down, if you'll notice, I have two triangles now, okay? I have a triangle that's smaller, like this, and then the larger triangle, okay? What you'll notice is that this is still a 30, and then this is still 60, you guys, and that's 90. It's still a 30, 60, 90. We have similar triangles. If I were to keep drawing parallels here, like to this 90, I would keep creating similar triangles. Okay, so what's interesting is that in this similar triangle, this ratio over this side, B over A, is still going to lead us to a 30, 60, 90. So every 30, 60, 90 has the same ratios. Okay, every right triangle is basically unique. Okay, it is its own triangle. So these ratios are so important for identifying the triangles that we give them certain names. Okay, and we've given them special names. So Actually, you know what I'll do? I have the ability to go back one. I'll do it here. Okay. I have some space here. So here's what we do. I'm going to draw any right triangle. Actually, I don't like the way I drew that one. Okay, let's try this again. Here. Okay, that's one side, two sides, draw this. You guys, anytime you have a triangle problem, draw the triangle. Okay, so here's our triangle. I'm going to call this, no, I'm not going to call that A. I'm going to call this B. It doesn't really matter, but I'm so used to calling this A and this B and this C that I like to put A here, B here, C here. All right, so to do trig, what you need to do is decide where you are standing. And you literally have to imagine that you are in the picture looking out, like this is your eyeball, okay? Or this is your eyeball, maybe, okay? Maybe you're looking from here. By the way, we hardly ever stand at C. That doesn't make any sense because C is the hypotenuse and you will see that it's not this, it doesn't operate in the same way. So first thing, know that you always have to have a right triangle to do any of these. It always has to be right. If it's not right, you can't use trig, okay? That's one of the mistakes people make is they forget. All right, so taking a look at this, if I'm standing, and I'm going to do this with green, if I'm standing at B, okay, I'm going to say we have three ratios, okay, we're going to say sine B is equal to, okay, and the sine is the ratio of B over C, okay, so the sine is the opposite over the hypotenuse. And in this case, that's B over C. Okay. So what they did is they're like, okay, so one of the ratios that's created is B over C, and that's going to be called the sine. Then they named another ratio of an angle. It's called the cosine. And the cosine is going to be A over C. It is the adjacent. Adjacent means next to. If you are adjacent to somebody, you are next to them. Over the hypotenuse. Okay, that's A over C. All right. And then the last ratio that they noticed from, if we're standing here from B, is going to be called tangent. The tangent of B is equal to B over A. And that is equal to the opposite over the adjacent. In other words, the tangent is B over A. Okay? So these three ratios were the first basic ones that we're going to be talking about, sine, cosine, and tangent. And if you've ever heard SOHCAHTOA, this is how you spell it, SOHCAHTOA. SOHCAHTOA is a mnemonic to help you remember what sine, cosine, and tangent are. Look, the sine is equal to the opposite over hypotenuse. Okay, see? Sine, opposite over hypotenuse. Okay, cosine is going to be adjacent over hypotenuse. So look, cosine is equal to the adjacent over the hypotenuse. And the tangent is equal to, okay, tangent is equal to opposite over adjacent. So tangent is equal to the opposite over adjacent. Okay? Kitty. Okay. So these have special names, these ratios, and they are unique to each triangle. So if you find the ratio, then you can identify the triangle. So like in the case of the 30, 60, 90, you don't know this right now, but a 30, 60, 90 has a sine of the sine B. Oh, well, I shouldn't say sine B. Let's say the sine of a 30-degree angle, which is B, okay? The sine of a 30-degree angle is actually equal to 1/2 or 0.5. If you were to plug this into the calculator, it will spit out a 0.5. Okay. And the reason why is because 30 degrees, the opposite over the hypotenuse, is equal to 0.5. That's just the way it is. That's unique. It's like its signature. Okay. So the idea is to first be able to identify these ratios. That's task number 1. Okay. So task number 1 is to be able to name the sine, cosine, and tangent of any angle. So let's take a look at this one again. Okay. I'm going to shrink it down just a little bit so I can get more in here. Okay. So when you're looking at this, the sine, cosine, and tangent of B literally means you are standing at B. You are looking out from B. Here you are. You're there and you're looking this way. Okay. So the opposite of B is B. Okay. And the hypotenuse is always C. Okay, that's an easy one, but the adjacent is A. Now let's say you wanted to stand at A instead. Okay, let's stand at A. Okay, well, that means you're here instead. Okay, and you're looking this way into the triangle. This is your eyeball here. Okay, so if we wanted to do the sine of A, again, sine is equal to opposite over hypotenuse. Well, here I am at A. The opposite, whoa, do that. This opposite is A over the hypotenuse, which is C. The cosine of A is equal to the adjacent over the hypotenuse. So what's the adjacent when I'm standing at A? Okay, the adjacent is B. So the cosine of A is B over C. And then the tangent of A is equal to opposite over adjacent, A over B. The only thing you really need to recognize is which side is the opposite. And that's easy. It's the one you can draw the arrow to and hit. Okay. Like if you're standing here, you shoot an arrow, you can hit it. Okay. You're not going to hit C. C is the hypotenuse and the adjacent is that other side. Okay. It's just though it's not the opposite and it's not the hypotenuse. That's the adjacent. All right. If you'll notice, these are just opposites of each other. Look, sine B is equal, BC is equal to the cosine of A. Isn't that interesting? Cosine of B is equal to the sine of A. They're both equal to A over C. Now, you don't really understand the significance of that now, and it's unique in that you can just see that it's kind of just plays to a really nice kind of simplistic ratio understanding. It's nice. Okay, I think basically that's the intro, okay, to trig. Okay, we're going to go to the basics now. Okay, it says a right triangle has side lengths. Okay, first of all, it's basically telling you exactly what's in the picture. It says use these lengths to find. Here's our task: sine x, tan x, and cosine of x. Okay, the sine x. X is telling you where to stand. Here's my x. That means I am standing right here and I am looking this way. Okay? So if you recognize if I'm standing at x, my opposite side, this is the opposite. This is the adjacent, and this is the hypotenuse. The first thing you want to do is identify your sides. Okay, once you have identified your sides, the whole ratio thing becomes very easy. Okay, identify your sides from the perspective of wherever they told you to stand. Okay, so sine x. Now remember, right? So, ka, to. Okay, sine is equal to opposite over hypotenuse. 9 over 41. Cosine of x is equal to adjacent over hypotenuse. Adjacent is 40. So it's 40 over 41. And tangent is equal to opposite over adjacent. Opposite is 9. Adjacent is 40. Now, I am assuming that Alex will want you to just put these ratios in as we We sometimes convert it to decimal. If converted to decimal estimation, because remember, this is exact. Once we convert it to decimals, it's an estimate. Estimation, we usually go to 4 digits. Usually, why did I dot that? Go to 4 digits to the right of the decimal point. Okay? All right. They'll tell you what to go. Sometimes it's safer to go to 4 digits. Okay? So that's it. You guys, that's it. Now, if I had asked you to go to y instead, what if I had asked you to do sine, cosine, and tangent of y? Here's what you would do. You'd start at y. You would go, oh, which side is my opposite? Okay, for y, this is my opposite. This is my adjacent. The hypotenuse is always the hypotenuse. Once you identify that, you're good. Okay, so the sine of y is equal to opposite over hypotenuse, 40 over 41. The cosine of y is equal to adjacent, 9 over hypotenuse, 41. The tangent of y is equal to opposite over adjacent, 40 over 9. Okay? That's all it is identifying the sides and putting it. So a right triangle has side lengths D, E, F. Okay? Use these lengths to find cosine, sine, and tangent. Now they're like, ooh, I'm going to take away the numbers, like as if that makes it any harder. It's basically the exact same thing, but it is telling you where to stand. Telling you to stand here at X. Identify your sides. First step, identify your sides. Opposite. This is adjacent, and this is hypotenuse. Okay? Write SOHCAHTOA if you need to, until you memorize what they are. Okay? So cosine of x is what they asked for first. Cosine of x is, cosine is adjacent over hypotenuse. So it's going to be D over F. Sine of x is equal to opposite over hypotenuse, E over F. Tangent of x is equal to opposite over adjacent. So it's E over D. Hopefully that isn't too confusing. It's really just naming these ratios. Next, it says find cosine of theta, where theta is the angle shown. First, I need to tell you about theta. Theta is a Greek letter. It looks like a 0 with a little curvy line in the middle. It's pronounced theta. I believe it's T. I might be wrong. For some reason, Trig uses a lot of Greek letters. This is alpha. It's A in our alphabet. This is beta, B, and then there's gamma. Okay, you don't have to know all these, but theta is a really common one. Okay, so's phi. Sometimes phi looks like this. It's a little W. Anyway, I just wanted to tell you that it's common to use it. Instead of X, Y, and Z, sometimes they use these Greek letters. All right, so it says cosine of theta, where theta is the angle shown. So here's theta. Theta is actually measuring this angle, okay? And when they say cosine of theta, that means stand at theta. Identify your sides. Okay, that's your opposite. That's your hypotenuse. Hypotenuse, by the way, if you can't figure out what the hypotenuse is, it's always the opposite of the right angle. Okay, so look, this is opposite of the right angle. This is the hypotenuse. Okay, this is the adjacent. All right, well, cosine is equal to the adjacent over the hypotenuse. Well, we don't have the adjacent. How can we do it? Okay, that's where you need to remember that you know about the Pythagorean theorem. Again, formula, substitution, resolution. A lot of you guys don't write the formula, and I think that's a terrible habit to get into. Okay, we don't have a squared. We have b squared, because b is 12, and c is 13. That's your hypotenuse. Remember, in the Pythagorean theorem, c is always the hypotenuse. So we get a squared plus 144. 12 squared is 144. 169, I believe, is 13 times 13. Why am I forgetting this? Yeah, it is. All right, and then we subtract 144 and we get a squared is equal to 169 minus 144. Look, it's 25, which means a is equal to 5. This is actually one of the triplets I talked about in the other one. 5, 12, and 13 is a really common triplet. You might see it a bunch and you might see it again. So if you know, like you have this side is 5 and the hypotenuse is 13, you kind of know the other side is 12. But if you don't memorize it, it's okay. You can always do the calculations. Okay, so a is equal to 5. So now we have the adjacent side, and now we can figure out the cosine. Notice it says give an exact value. That means do not plug it into the calculator. Just type it in as a fraction. In geometry, we love fractions and exact answers. Square roots are okay with us, okay? You can't leave it in the denominator, but you can leave it in the numerator. Anyway, adjacent is 5, hypotenuse is 13, and that's your answer. Next. Now it says find sine, cotangent, cosecant. Okay, those are new. We haven't talked about those. Okay, so we're going to talk about them right now. So I told you when you have a triangle, these are more just general notes, okay? When you have a triangle, you have A, B, C, A, B, C. The capital letters mark the points, remember? Okay, well, we had sine is equal to opposite over hypotenuse, and cosine, oops, I'll put theta, okay? Equal to adjacent over hypotenuse, and tangent of theta is equal to opposite over adjacent, okay? So we have these ratios, but we decided to name the inverse, okay? So we're going to name the hypotenuse over the opposite, and we're going to name the hypotenuse over the adjacent. All we're doing is flipping these things, and we're going to provide a name for the adjacent over the opposite, okay? This one is an easy one. Tangent, guess what? Its inverse is called cotangent. See, tangent, cotangent. That makes sense, right? Well, this part is not going to make sense to you. Cosine, the opposite, this one, the name of it is called the secant of theta. Notice it starts with a C, its inverse starts with an S. And get this, the inverse of sine is cosecant of theta equals cosecant. Get it? Look, C goes with S, C goes with S. It's the opposite of what you would think. You want to put the C's together, but they don't go together. And I should probably have put that there. CSC is equal to cosecant. Okay? SEC is equal to secant. And COT is cotangent. Okay? So we now have 6. These are the 6 basic ratios that we talk about in very beginning trig. Okay? These 6 ratios. Okay? You will also notice that cosecant is also 1 over sine. Okay? I don't know if it'll come into play, but I'm going to write it down. Cosecant is also equal to 1 over sine of theta. Get it? It's the inverse. Okay? And it flips it. Secant is 1 over cosine of theta, and cotangent is 1 over tangent of theta. Okay? These are just properties. All right, so it says find sine, cotangent, and cosecant from theta. Here you are. This is your eyeball. Just remember that. You're standing right here. You're looking out. Identify the sides. I always draw an arrow to the opposite. Here's the adjacent. Here's your right angle. That means this is the hypotenuse. All right, so we need to find the sine of theta. The sine of theta is opposite over the hypotenuse. Okay, so it's going to be 5 over O. We don't have it. We have to find it. So we're going to have to use the Pythagorean theorem. The Pythagorean theorem is your best friend when working with right triangles, as is trig. So 3 squared plus 5 squared equals c squared. We don't know what the hypotenuse is. All right, 9 plus 25 is equal to c squared. 9 plus 25 is 34 equals c squared. So guess what? C is equal to the square root of 34. Is there anything we can take out? 34 is 2 times 17, so no, this is it. We're going to leave it here, square root of 34. Okay, so let me actually do that. Let me shrink it down a little, and let me erase this because I shouldn't have put it here. This is not a good place for it. Okay, let's put it here. C is equal to the square root of 34. Okay, so sine is equal to 5 over the square root of 34, but this is why we did radicals, you guys. You cannot leave the square root on the denominator. That is against, it's illegal, against the math, illegal math. Let's call it illegal math, okay? You need to rationalize the denominator. So we're going to multiply it by the square root of 34 over the square root of 34. So 5 times root 34 over 34. And you ask, can I simplify that further? And the answer is no. 5 and 34 have nothing in common. So this is your answer for sine. Okay, what are we going to do for cotangent? Cotangent, write these down, by the way. You need them. You need them on a piece of paper, so you have them handy. Cotangent of theta is equal to adjacent over opposite. So adjacent is 3 over 5. And that's easy, right? That's it, 3 over 5. Okay, so that's that answer. Then we need cosecant of theta. Well, the cosecant is hypotenuse over opposite. So it's the square root of 34 over 5. And we don't need to rationalize anything because it's on the top. And those are your 3 answers. So just basically take these ratios, look at them, use them as a key. Okay, what side do I put over? What side do I put over? Okay, and that way you can remember them. Next. All right, this is super easy. This is just calculator. I do want you guys to know that you could do this. So I am going to go to, what's it called? Desmo Scientific. And then we are going to go ahead and put this in. Okay, to find it, oh, it's right there in the front. Check it out. There it is. So if you want to do the sine of anything, remember I told you the sine of 30 is equal to 0.5? There it is. Okay. And guess what? If the sine of 30 is equal to 0.5, guess what the cosine of 60 is? Ready? Boom, 0.5. It's the same. All right. So all you have to do is plug in these numbers. Cosine 41 or 40, whatever. Okay. And you get, wait, why did I put the cosine of the cosine? Okay. All right. So that's plugging it in. Okay. If you were trying to find the cotangent, you can either do it by hitting functions. I would imagine they might have it. Okay. So you see this sine -1, cosine -1, tangent -1? That is the cotangent. That is the, no, that's not. It is not. Never mind. Sorry. This is how you go from angle to side. Let's see. So if you were just doing, you know what? We don't typically do cotangent typically, but a lot of times it will have it as its function. I wonder if it's here. No, it's not here. It's not here. I wonder if you could just do it. Let's see. Cotangent of 30. Oh, can't do it. Can you do 1 divided by the tangent of 30? Maybe that's what you would have to do. If they wanted you to figure out what the cotangent is, you might need to do 1 divided by tangent of 30. I don't know if that'll come into play, but anyway, you have to figure a way around it. But I don't think that's definitely not what we're doing right now. You're just plugging these in. Pretty simple. I'm not even going to do it because it's that simple. Oh, I do want to point out, it says to the nearest hundredth. So I said to the nearest fourth. That's when you're actually working with triangles and trying to solve them. But they want you to round it off to the nearest hundredth. Okay. All right. It says for each triangle, find the ratio of the length of the side opposite 41.7 degrees to the length of the side adjacent. So they're asking you to find the opposite over adjacent. That is the tangent. Note that the side adjacent cannot also refer to the hypotenuse. Okay, so here's what they're trying to show you. They're really just trying to show you that these are going to be similar triangles. Because look, you guys know that if you have two triangles by the angle-angle theorem, okay, if you have two angles, you know that third one's the same. So we know these triangles are similar, okay? So BC over 7.54. It says round to the nearest hundredth. So what you would do is you would take 6.72 and divide it by 7.54. And then this one you'd be 20.16 over 22.62. Now you're not going to plug this in. You're going to plug it into the calculator and put the answer, NYZ and over XY. And what you'll find out is you're going to get the same answer because these are similar triangles. Use the Alex calculator to find this sine, cosine, and tangent. Okay, that's just a calculator question, no problem. Which trig function gives each ratio of sides in part A? And that is tangent, because tangent is equal to opposite over adjacent. Okay. By the way, we always need to put where we're standing and an equal sign. So I'm sorry for that ugliness that I just wrote. This is equal to tangent of A. Okay. Or tangent in general is opposite over adjacent. Okay, next. In the figure below, they're telling you they're similar. Remember, that's the similar. That means that they have all angles the same, remember? So that means they are proportional. All angles are the same. Therefore, that's a cool little symbol for therefore. 3 dots. The triangles are proportional. Okay. So find tangent y, sine y, and cosine y. All right, so here's what they did. They gave you a triangle that has no measurements, and they're asking you to do that. But what they're really asking you to recognize is that you have two similar triangles, and they purposely turned this triangle weird so that you wouldn't understand or that you'd have to think about it. So what I always do with these is I rewrite them, okay? I rewrite them. And this side corresponds to the A. So this is Y. And then this Z corresponds to the B, right? And then C corresponds with X. Okay, so now we know we're standing here. We're standing at A. We're standing at Y, but basically we're standing at A because these are proportional. So the tangent is equal to the opposite over adjacent. Tangent is going to be 8.4 over 24.5, and you're going to round it to the nearest hundredth. I'm not going to do it for you because that's not the hard part. Plugging it into a calculator is not hard, okay? And that's it. So basically the problem on this one is just to flip this triangle so that it looks the same so you understand which points correspond. All right, solve for X. Now we're going to be looking for a side. Okay, you guys, this is the next level of understanding. Whoa, sorry about that. Let's try to go back to normal. Let's move this over. Okay, there we go. Okay, so instead of finding just simple ratios, now we're going to use those ratios to do what's called solving a triangle, basically finding all the sides and all the angles, okay? But in this case, all we're looking for is for X, okay? We're looking for this side. So here's how you solve this problem. You guys take a look at it. What you're going to be looking for is what you're going to try to do is find the ratio that works with I don't know why I put an E at the end of that. That was weird. Sides given. So in other words, here I am at my angle. Here I am standing. Okay. I'm looking out this way. What sides are we talking about here? I have opposite and I'm looking for adjacent. So what relationship in sine, cosine, so TOA. Which relationship am I looking for here? Or which relationship can I use, rather? So I have opposite and I'm looking for adjacent. So which relationship deals with opposite over adjacent? Tangent. This one involves the hypotenuse. We're not looking for the hypotenuse. So we shouldn't find it. We could find it, but that would be dumb. We're looking for the x. Okay, so we're going to put, or I guess it wouldn't be dumb. It would just be like really going around the box, around the way to get to the end. Okay, so we're going to say tangent of 63 degrees because we know what it is. It's no longer unknown. It's not just A. Okay, tangent of 63 is going to be equal to 7 over x. All right, the tangent of 63 has an answer, you guys. I highly recommend you do not plug it into the calculator yet. Let's get that x on top. Okay, how do we get the x on top? One is you can recognize this as a proportion and cross multiply. Or you can recognize that you want to get rid of the denominator, you want to bring it to the top, so we multiply by it. That's the trick. So then I have x tan 63 equals 7. But I don't want x tangent of 63. I want just x. The tangent and the 63, they have to go together, you guys. You can't just divide by 63. Tangent is a word. It means take that of 63. So you have to divide by it. Tangent of 63 on both sides. And then you get x is equal to 7 over tangent of 63. You can plug that into your calculator and round it to the nearest tenth. A lot of times we round angles to the 100th and sides to the 10th. Just kind of convention. Okay? Okay, so the idea is that you pick the side. So in other words, had I given you a triangle like this, and I said, find y, and I said, this is 42, and it's a right triangle, and I gave you 6 here. Okay, and I said, find y. You have to stand at the angle, stand here, the one that you're looking at, okay, and identify the sides. I have adjacent and I have hypotenuse, or I'm looking for hypotenuse, right? I can only have one unknown. I have to have only one. So adjacent over hypotenuse. All right, which one is that one? Cosine. So I would use cosine of 42 is equal to adjacent over hypotenuse. And then again, I would multiply by y and solve for y. And it would be y is equal to 6 divided by cosine of 42. That's how it works out once you divide it out. All right, that's what you have to do is identify which relationship they're trying to get you to use or that you could use to solve this problem. And that is the end of this video.